This last section of chapter 5 is still on multiplication, but it's about shortcuts. And what do I mean by this? Suppose I have to multiply x plus 5 with x minus 5. Okay, so if I use the method from the previous section, I would do x times x minus 5 plus 5 times x minus 5, and I would get I could even skip that step, right? Remember, I have to do x times x, x times minus 5, 5 times x, 5 times minus 5. So that's exactly what I'm going to get in my next step here. So x times x is x squared, x times minus 5, minus 5x, 5 times x, 5x, and 5 times minus 5, minus 25. And I noticed that by regrouping like terms, these terms cancel out, and I'm just left with x squared minus 25. Now, if you observe things carefully, it looks like this is the first term squared. Right? This first term here. And the 25 here, that's the second term squared. Second term, this term here. Okay. Is that a coincidence? Okay. Well, no. So in fact, we'll obtain a formula that allows us to go directly from this expression to this one. So we'll be skipping those two steps in order to get the answer. So it's just a shortcut. So of course, everything that you've seen in 5.5, you can use it. It'll just take you longer to do problems from 5.6. But ultimately, 5.6, you want to be able to use those shortcuts to go, well, first thing to go faster, but also when we're, I told you that right now we're focusing on expanding polynomials, but later on we'll want to do the other way, go the other way around. It's going to be important to know those shortcuts when we want to go from an expanded polynomial to a factored polynomial, to a polynomial expressed in terms of a product of simpler polynomials. So the first formula I want to show you is when you have something of the form a plus b times a minus b. So that's exactly what I had in my introductory example. You see, I had a was x and b was 5. You see, I had a x plus 5 times x minus 5. That's of the form a plus b times a minus b. But I'm considering any possible any expression that can be written down this way. So ultimately, you'll see that I'll have examples where see, well, I can even write down my next example, what I want to look at with you. It's 3x plus 7 times 3x minus 7. So you see, that's my a here. A is 3x now, and b is 7. Okay, so I want to have a formula. So I'm going to perform what I just did up there, okay, with my a and my b, and simplify and get something that's a lot simpler. So to multiply this out, I need to multiply a with a, so that's a squared. A with minus b, that's minus ab. B with a, that's ab. And b with minus b, that's minus b squared. And you see that, just as in my previous example, the middle terms cancel out, and I'm just left with a squared minus b squared. So I'm left with the first term squared minus the second term squared. So if I notice that I have something of the form a plus b times a minus b, right? I can perform this multiplication a lot faster. So in the example here, 3x plus 7 times 3x minus 7, first term is going to be 3x squared, second term 7 squared. So that's going to be 9x squared minus 49. Obviously, I can skip this part once I've become good at this. Okay, so in one shot, poof, I've got everything multiplied out. Here's another one. I've got 2x minus 6y times 2x plus 6y. So once again, that's of the form a minus b times a plus b. So it's a squared minus b squared. So that's 4x squared minus 36y squared. So that's way faster than expanding everything and simplifying. Second formula, when I have something of the form a plus b, that is squared. So that's a binomial squared. So let's see what the formula is like. So that's a plus b times a plus b, right? By definition. If I multiply all the terms together, a with a is a squared, a with b is ab, b with a is ab as well, b with b, b squared. Okay, so that's a squared plus 2ab plus b squared. So that's also something to remember. Oh, I noticed now that I should have framed my first identity. Let's write it here. So a plus b times a minus b is a squared minus b squared. So that's the first identity to remember. And here's the next one. A plus b squared is a squared plus 2ab plus b squared. So let's see how we can apply this to an example. So I've got 2 plus 3x squared. So that's of the form a sum of two things. You can call those a and b. That's squared. So according to my formula, it's the first term. So the a, that's squared. So 2 squared plus 2 times ab. So it's always 2 times the product of each term. So 2 times 2 times 3x. Plus the last term squared, like that. So that's going to give me 4 plus 2 times 2 times 3. So that's 4 times 3, 12. X plus 9x squared. If I have a minus b squared, okay, well, that's a minus b times, so this would be, well, we call that formula 3, but it looks a lot like formula number 2. So it's a minus b times a minus b, so it's going to be a times a squared, a times minus b, minus ab, minus b times a, minus ab, minus b times minus b, plus b squared. So that gives me a squared minus 2ab plus b squared. So there's a strong similarity between the two formulas. In fact, I can sort of summarize the two formulas in one frame. So that's the one we just had just before. If instead of a plus I have a minus, so sometimes we'll put plus minus, and we'll put the minus also here. Okay, if you see a formula with the minus up there, it means that when it's a plus to the left, it's a minus to the right, and when it's a minus to the left, it's a plus to the right. But in our case, when it's a plus, right? When it's a plus here, it's a plus here. When it's a minus here, it's a minus there. So I will put the minus below, like this. So that's a formula that generalizes this one, and, well, that summarizes this one and this one. Okay, star and double star. So this is star and double star all at once. So maybe another example here. Imagine I have 2 minus 3x squared. Well, that's going to be the first term squared, a squared, minus 2 times a times b, plus b squared. So that's going to be give me 4 minus 12x plus 9x squared. There are two ways to look at this, by the way. I could also look at it from the point of view where this is 2 plus minus 3x squared. In that case, I'd be applying the formula for a plus b. So let's check that it gives me the same thing. So that should be a squared plus 2 times a times b plus b squared. And let's see, I get the exact same thing. I get 4 here. I get 2 times minus 3, so that's minus 12. So that becomes minus 12x. And minus 3x squared, that's minus 3 squared, so that's 9 times x squared. So I do get the exact same thing, okay? Whether I see that as a plus b or a minus b squared, okay? So there are two ways to go about this problem. So so if you write it down this way, because there's a plus sign between your terms, you have to apply the formula with the plus sign. But if you keep the minus sign there and not change anything, you have to apply the formula with the minus sign here. Maybe a last example before we finish this. Let's say I want to do 1 plus x plus y times 1 minus x minus y. Now that doesn't look a lot like anything we've done so far, because all the formulas that we have, they apply when to what something where we have every formula that I have only 2 terms added or subtracted inside my brackets. So here I have 3, right? 1 x y or 1 minus x minus y. So I have 3 terms each time. So it seems like I can't apply any of the stuff I have before. But here's a little neat trick to look at. I can regroup the x and the y together and do the same thing on the other side. I can write it as minus x, 1 minus x plus y. And now look at that. Now I've got something of the form a plus b, and here a minus b. Oh, and now I can apply my first formula, this one here. So it's going to be a squared minus b squared. So that's a squared, 1 squared, minus b squared. So that's 1 minus x plus y squared. And to expand this second term, I'm going to be using this formula here. So this is 1 minus, and let's put everything in brackets because that minus is going to distribute over everything. If I don't put brackets, it will only apply to my first term, and I want it to apply to all the terms. I want, because it's minus x plus y squared, so I need to write x plus y squared inside my brackets here and then distribute my minus sign. So x plus y squared is what? It's x squared plus 2xy plus y squared, and ultimately I will distribute my minus sign. So you see the problem, if I don't put brackets, that's not equal anymore, because the minus sign would only apply to minus x squared, to x squared, but it needs to apply to everything. So that's why the brackets are so important in my second to last step. And then I'm done. I could reorder my terms so that you know, they go from smallest degree to largest degree. Okay, but that's just me. I mean, you don't really have to do this. Also, if this example you think that you wouldn't have been able to solve it because you would not have been able to recognize that the formula a plus b times a minus b applies, doesn't matter, right? You can always fall back on or expand your polynomials without using any tricks. Just fall back on what you've learned in the previous section. So if I could have also not notice anything and just do my multiplication. So in this case, I would have done 1 times 1 times 1 times minus x times 1 times minus y. Let's do this very quickly. You see, it's going to give us the exact same thing. And then I do x times 1, x times minus x times minus y, and finally y times 1 minus y times x minus x minus y squared. I regroup like terms. I get 1 minus, I get minus x plus x, so that cancels out. I got minus y plus y, that cancels out. I got minus x, y minus xy, so minus 2xy minus x squared minus y squared. So I get the exact same answer, right? This is the same answer as here, okay? But it's cute when you realize that you can actually use one of these shortcuts that are appear in this section. Sometimes it gets you to the answer a bit faster. But mostly those formulas, they'll be interesting. It will be interesting to use them when we want to go from an expression given like this to this. So in a later section, we're going to want to go backwards. And from an expanded form of a polynomial, we want what's called a factored form, a form expressed as a product of simpler polynomials.